Good morning. We were discussing the very important process in air conditioning, namely cooling and humidification. Today I would be talking about something else, which is another important process in desert cooler and how to determine its effectiveness or efficiency. So desert coolers is basically, in layman's language, we call them as simply coolers, and the psychrometric process involved, as we had already discussed earlier also, that the psychrometric process involves not only cooling, that is reduction in driver temperature, but also increase in the moisture content, that is humidification. So if you want to represent this process on the psychrometric chart, this process of cooling and dehumidification is also called as adiabatic cooling, because generally there is, ideally we could say, that the heat transfer is zero and the enthalpy is constant. So it means the process of cooling and humidification would move along a constant enthalpy line. So this is a constant enthalpy line, say 1, and let us say this is your 2. So 1 to 2 is a constant enthalpy line, and it also happens to be a constant WBT line. Constant WBT line. So adiabatic cooling process, if I want to represent on the psychrometric chart, then it can be represented as a line as shown in this diagram, where I suppose one is the initial state, which is at the entry to the cooler. I move along the constant enthalpy line until it touches the saturation curve. So that becomes the process called adiabatic cooling. As you see in this diagram, you see that the temperature, the dry bulb temperature reduces from T1 to T2, and the specific humidity or humidity ratio, it increases from omega 1 to omega 2. So this is very clear that the temperature is reducing and the specific humidity is increasing. Now, how do I estimate the performance of this cooling and dehumidification? So there are namely two parameters. One is called as a spray efficiency. One is called as a spray efficiency, and other is called as the humidifier duty. So what are these terms that I will be explaining you in brief? What exactly do you mean by spray efficiency during the cooling and humidification process, and what is the humidifier duty? Now, again, if you consider the process, let us say this is a psychrometric chart, and as I said that in cooling and humidification, we move along the constant WBT line or constant enthalpy line. So if the initial state was 1, T1, T1, so initial state, that is the climate, let us say, is hot and dry, and there is some temperature T1, let us say, some value you can take, let us say it is 30 degrees centigrade. Okay, now using this cooler or desert cooler, how much we can cool? Theoretically, up to what temperature we can cool? So this is a very interesting question. Can we cool it up to, let us say, 15 degrees centigrade, as you do it in your air conditioning apparatus? Can I cool this hot and dry air up to, let us say, 15 degrees centigrade in a desert cooler? The answer is no. Why is that so? That is because the minimum temperature one can achieve, the minimum temperature, theoretical minimum temperature one can achieve by using a desert cooler is T1 dash. And where is the T1 dash? Suppose this is 1, so this is 1 dash. 1 dash is on the saturation curve. 1 dash is on the, it is a WBT, okay, WBT, and so the corresponding WBT, so suppose this is the DBT of the hot and dry air, so the corresponding WBT would be T1 dash. So the maximum cooling one can achieve is from T1 up to T1 dash. And what is T1 dash? It is the corresponding WBT of the initial state. So you cannot cool below T1 dash. That is a disadvantage of desert cooler. When you cannot cool below T1 dash, that is a disadvantage of desert cooler. Now this is ideal now. So ideally what we are expecting now? We are expecting that ideally the temperature would drop from T1 to T1 dash. That is the ideal drop. Okay. So ideally the drop is from T1 to T1 dash. However, actually we would get a temperature which is a bit higher than T1 dash. So let us say that temperature is T2. The temperature is T2. It means this is 1, this is 1 dash, and this is 2. So you see that this 2 to 1 dash is not achieved. This drop is not achieved. 2 to 1 dash is not achieved. And in order to capture this, okay, how much we can achieve and how much we are not able to achieve, we define what is called as the efficiency of the cooler. Efficiency of the cooler, or it is also called as spray efficiency. Spray efficiency. So how do we define spray efficiency? For defining spray efficiency, what we do is that we consider what is achieved. So what is achieved is the drop T1 minus T2. And what is not, what was expected to be achieved, what was the ideal to be achieved? It is T1 minus T1 dash, T1 dash, or T1 dash is what? T1 dash is nothing but WBT. T1 dash is nothing but WBT. Okay, so the efficiency formula now becomes, spray efficiency formula becomes T1 minus T2 upon T1 minus WBT. Is this clear? How do we find the spray efficiency of the cooler, desert cooler? We find the spray efficiency of the cooler as T1 minus T2 upon T1 minus T2 dash. And the next concept is of the duty. The duty of the cooler. Duty means how much water we need to add to the cooler. Okay, because why is the water to be added to the cooler? The water needs to be added to the cooler because some of the water gets evaporated. So we need to calculate what is the makeup water to be added to the cooler, which is nothing but the duty. So how much would be that? So it would be equal to the mass into how much is the increase in the specific humidity. So duty of the cooler is calculated as mass into omega 2 minus omega 1. So this much amount of kg of water, not water vapor, water needs to be added. This much amount of water needs to be added to the cooler. This is called as the duty of the cooler. Okay, this duty I can also express in terms of CMM. Okay, I can also express this duty in terms of CMM. So duty in CMM would be what? So I express the mass in, mass is what? It is the volume upon specific volume. So volume is CMM upon specific volume in meter cube per kg into omega 2 minus omega 1. Okay, so this much kg of water, not water vapor, has to be added per minute to the cooler. This is the duty. If I want to express this in hours, how much amount of water every hour is to be required to be added, then what I do is that I multiply this with 60 into 60 omega 2 minus omega 1. This is P1. Okay. So for calculating the duty of the desert cooler, how much water is to be added, what I do is that I take the CMM, divide it by specific volume at state 1 and multiply it with omega 2 minus omega 1 into 60 would give me the kgs of water to be added every hour. Every hour. So this you have to remember well that there are two concepts in adiabatic cooling or cooling and dehumidification. One is to find the spray efficiency, one is to find the spray efficiency, that is T1 minus T2 upon T1 minus the corresponding wet bulb temperature, and the other is to find the duty, which is V upon V into 60 into omega 2 minus omega 1. Thanks a lot. Meet you in the next video.